So decide whether the pairs of triangles are similar, giving reasons. So let's have a look here. If we went from, say, 2.5, that's the small side, to 1. So what you can do to check if they have gone up or down by the same scale factor, what you can do is you always say the original over the copy or whatever, the next one. So here I'm going to call this the original and this one the copy or whatever. Okay, so if I look at those sides, so see here, this was 2.5. That's the larger side, smaller side on this example. So I'll go 2.5 over 1 equals 2.5. Okay, so that's what that for this side. Now, what about if I check the other side? So I'll say 5 is the bigger side and things. So if I do 5 divided by 2, what do I get? I get 2.5. You'll get 2.5. So see how they actually, that's the scale factor, isn't it? Yeah? So the scale factor. It actually went, so it's, because it depends which way you went. So if we went like that, it reduced by 2.5 or increased by 2.5, whatever, okay? So we're going to say they have the same, and then is the angle the same in between them? Yes. So we're going to say, yes, they're similar. And why are we going to say they're similar? Because, yeah, we're going to say side, angle, side. Okay. So let's go check the next one. So if we look at, if this is 30 and this is 95, we know that the last one, we've got to add up to 180. So what would that one be? That'd be 55, 45? No? 55? 55. So, but because these two are both the same, that's going to be 55 too. So are these ones similar?
Yes.
Yes. And why? Angle, angle, angle. A. All right, awesome. A couple more. So it says, if the given pairs of triangles are known to be similar, so we know that they're similar, find the value of x. So what you're going to do is, if you know they're similar, you know how before when we did the fraction, we said if we use the original over the copy or whatever, we ended up with the same number, didn't we? So we can do that here. So I might say, see how we can see this angle and that angle? It's the same. So this 4 and the 2 are the same side, aren't they? So I'll say the original 2 over 4 should give me the same number as if I said the 3 over the x. Is that true? Because they're telling me they're similar. So once you get it like that, you know they should equal because it's similar triangles. All you have to do is you can use your solve function on your calculator and you type this exactly out like that and we do comma x. So who can tell me how do we get the solve on our menu? 3, 1. And just remember to do the comma and the x. Okay? How do we get the fraction template? Control, divide. Okay? Good. So we can see that x is 6. Alright, so someone said they could see that this was times by 2, so they times that by 2, so we got 6. Yeah, that's easy, but what about if it's a fraction, it's not gone up by the same, it gets a little bit hard? This solve and making each one equal each other will work for everything. So if it's a little bit harder, just do it like this. Alright, let's go on to this last question. If the given pair of triangles are known to be similar, so we know they're similar, find the value of x. So if you look here, got to be careful. This is the hypotenuse, yeah? So this one is the same as that one. Would that be true? Yeah. So if I call this the original and this the copy, okay, so I can say, so the original over the copy. So what I can say is that 6 over 9 needs to equal 3 over x. Yeah? And so then we can do solve. 6 over 9 equals 3 over x, comma x. And then we find out what's that. Alright, so you get x equals 4.5. So there's an example where it wasn't as easy. So you might not have been able to see the multiplication, so better to use the solve. The other day, everyone did the question for all of them, and today I said you would finish with question 5, doing all. So we're still on exercise 7F.